Welcome back to Summarize Science. Have you ever wondered why AI assistants sometimes struggle with very long documents or why they can feel a bit slow? A big part of the reason lies in the fundamental architecture that powers most of today's large language models, the transformer. But what if there's a better design that could make AI faster, cheaper, and more powerful all at once? In this paper, researchers perform a massive head-to-head comparison between the reigning champion, the transformer, and a challenger called xLSTM. Think of the transformer as a powerful engine that gets exponentially less fuel efficient the faster you try to go. Its processing cost skyrockets when it's given more text to read. xLSTM, on the other hand, is designed with efficiency in mind, promising linear scaling, which is a much more manageable way to grow. The first major finding is that xLSTM is Pareto-dominant over the transformer. Looking at this graph, for any given amount of training compute, represented on the horizontal axis, the xLSTM line is lower, meaning it achieves a better, lower, loss score. In simple terms, for the same amount of money and time spent on training, you get a smarter model with xLSTM. Alternatively, to reach a target level of performance, xLSTM requires less computational effort. It's like getting both better performance and better fuel economy. But the most crucial difference appears when we look at context length, how much text the model can remember at once. For a transformer, as the context length increases, its quadratic costs for the attention mechanism become a huge burden. To stay within a certain compute budget, the optimal transformer model actually has to get smaller and less complex. In contrast, the optimal xLSTM model size remains stable, even with much longer contexts. This means xLSTM can maintain its full brainpower while reading a novel, whereas a transformer would struggle. This all leads to the most important part for us as users, inference speed. These charts show how long it takes to get the first word back and how quickly it generates the rest of the text. At short prompt lengths, they're similar, but as the prompt gets longer, the transformer gets much slower, while xLSTM's speed stays consistent and fast. The results are dramatic. For a long 16,000 token prompt, the largest 7 billion parameter xLSTM is actually faster at generating text than the smallest 160 million parameter transformer. That's a massive performance advantage. This is the linear versus quadratic complexity in action. So let's recap the important points. The researchers showed that xLSTM models are more efficient to train, they scale better with increasing context length without having to sacrifice model size, and they are significantly faster in real-world use. This positions xLSTM as a very promising and scalable architecture for future language models. This could mean AI that can read entire books to answer a question, analyze complex legal documents in seconds, or even run powerful applications right on your phone without killing the battery. It's a big step towards making powerful AI more accessible and capable than ever before.